Hello everyone, this is Mr. McMillan, and I'm here with the third part of the transformation instructional videos. And then this video, we're going to be talking about rotations. So rotations, as you might be familiar with, are where we turn the figure in a certain orientation. So rotations are just turning figures, okay? Now, of course, you can turn a figure left or right. So for example, this pen, I could turn it left and I'm rotating it here by a certain number of degrees. Okay. Now, but in the coordinate plane, we tend to only rotate about, points. And specifically, the center of rotation is almost always assumed to be the origin, which of course is located at 0, 0, unless told otherwise. So if the problem says to rotate at a different point, then it will tell you. But for the purposes of this class, it will typically only talk about the origin point. Okay, it's very rare that it actually talks about any other point than the origin. So rotations can occur in one of two directions. They may be clockwise rotations, or they may be counterclockwise rotations. Okay. And I know in many situations, the analog clock has been replaced with digital clocks in most places. But if you remember an analog clock, you've got the minute hand and the hour hand and the seconds and all that stuff. And so you have something that looks like this, right, with your clock. And the hands, which way do the hands go? Do they go right or do they go left? Well, if you've ever watched a clock, you can see that it ticks slowly to the right, and it goes in a clockwise fashion. So clockwise is considered to be going to the right. Okay, so I'm going to put a little arrow there and a C for clockwise. Now, of course, counterclockwise would have to be the opposite way. So the counterclockwise, you would start by going left from the top and go in a complete circle. And that's your counterclockwise direction. Now, when you're talking about the coordinate plane, most of the time your rotations are assumed to be counterclockwise unless otherwise stated. Sometimes it does state a 90-degree clockwise rotation, but most of the time it's counterclockwise. And the reason for that is the way the quadrants go naturally. So if you have a coordinate plane, you have quadrant 1 starting in the top right, quadrant 2 in the top left, quadrant 3 in the bottom left, and quadrant 4 in the bottom right. And so in order, they go 1, 2, 3, 4, starting in a counterclockwise fashion. Okay, so quadrants go counterclockwise. So typically when it's not stated, rotations are assumed to be counterclockwise. Now there are typically 4 different types of rotations. We only talk about 3 because the last one, the 360-degree rotation, will just have it end up being a full circle. And so you just end up back where you started. So we're not really concerned about that one. But the ones we are concerned about are the 90-degree rotation, the 180-degree rotation, and the 270-degree rotation. Okay, so any of those we are concerned with. So let's look at each type of rotation in more detail. So the first one is a rotation 90 degrees counterclockwise. Okay, so to determine the coordinates for the image of a 90-degree counterclockwise rotation, you first change the sign of y only. So you start out initially, you change the sign of y, And then after you change the sign of y, you switch x and y. You don't do anything else with the x other than switch it with the y. So this gives us the mapping rule, x comma y maps to, we're going to change the sign of y, so that's negative y now, and then switch it into the x position, and then x goes in the y position. So for instance, if you had something like the point 3, 1, like A is here, you make the 1 negative because it's in the y position, and then you switch and you have -1, +3. Okay, so that's what we're saying that A prime is going to be. So we'll check that in just 1 second. Now there's an easier way if you have them physically on your paper or you have them drawn. You can actually physically turn your paper in a 90-degree rotation or 180 or whatever else. Now the important thing is getting the direction right. So if it says counterclockwise, a 90-degree counterclockwise is 1 turn 90 degrees to the left, like so. Okay, so this is your figure rotated at 90 degrees counterclockwise. Now ignore these numbers here and just look here. Your coordinate grid is still there, and now you have a new coordinate grid. You've altered the picture and transformed it to make it look like it's supposed to look. So let's look at the coordinates of A. So A, we start at the origin and we have to go left 1. So A is at -1 for the x coordinate, and then we have to go up 3. So A prime would be at -1, +3. So we'll go ahead and plot that, -1, +3. And if you remember from the initial part, that's actually what we said A prime would be using our mapping rule. Now we can rotate our paper back. And now let's look at B. What are the coordinates for B prime? Well, you have to go left 1, up 6. So your coordinates for B prime would be -1, +6. And you do your last coordinate for C. You have to go left 6 and then up 6. So C prime would be -6, 6. Now, if you look here, if you were to rotate your paper 90 degrees counterclockwise, would this figure be in the exact same location and the exact same orientation as this one rotated 90 degrees? And the answer is yes, it would be. Okay, so this is a simpler way to do it without having to rely on remembering a formula if you can physically turn your paper. Now, if it's something like on a computer, then you could always draw that on your own paper and then go from there. Okay, so that's always an option for you. So let's look at our next rotation. The next rotation is a 180-degree rotation around the origin. So when considering the coordinates for a 180-degree rotation, this requires us to change the signs of X and Y. We have to change the signs of X and Y. We don't switch them, we just change their signs. So the mapping rule, X comma Y, all we're doing is changing the signs of X and Y. So X becomes -X and Y becomes -Y. Okay. Now, when you're doing a 180-degree rotation, take for example my pen, right? You have a start here at the top and the tip of the pen is pointing upwards, right? And if I do a 180-degree turn to the left, counterclockwise, it is now pointing downward. Well, if I start from the original position and do a 180-degree turn clockwise, you end up in the same position. So regardless of the way you turn your paper, 180 degrees is the same whether it's counterclockwise or clockwise. So I'm going to first determine the new coordinates using the formula. So D is at 4, 1. E is at 2, -3. And F is at 6, -3. Now, for a 180-degree rotation, all we do is change the signs. So 4, 1 is going to become -4, -1. 2, -3 is going to become -2, +3. F prime is going to become -6, +3. All we did there was just change the signs of both of them. Now we're going to do this, we're going to plot it using the rotation method, and then we're going to compare what we plotted to see if it is indeed the same. So with a 180-degree rotation, we are going to end up with our paper being upside down. So let's go ahead and do that. So your new coordinates for D, you have to go left 4, down 1. So in other words, your coordinates are -4, -1, and that matches up with our D prime. So we're going to plot -4, -1, D prime. Then we rotate again. E would be at -2, +3, because we have to go left 2, up 3. And that matches up with our coordinates for E prime. So -2, +3. And then finally, F. F, our new coordinates for F, we have to go left 6, up 3. So -6, +3. And then we just connect our sides. And we go from there. And if you'll notice here, all of these coordinates lined up exactly with how our rotated figure should be, just by using the rule. All right. So the last rotation we're going to look at is a 270-degree counterclockwise rotation. But I also want to point out that a 270-degree counterclockwise rotation is the same thing as a 90-degree clockwise rotation, okay? And we'll talk about what that means in just a second. So to determine the coordinates for the image for a 270-degree rotation, first we change the sign of X only, and then we switch X and Y. So just like the 90-degree, except we change the other coordinate. So your X comma Y, you change the sign on X, so it becomes -X, and then you switch X and Y. So this becomes Y comma -X. Now, 270 degrees counterclockwise. If 90 degrees is one turn to the left, and 180 degrees is 2 turns to the left, then 270 degrees counterclockwise is 3 turns to the left. 3 90-degree turns to the left. However, we can also do a 90-degree clockwise rotation, and that would just be 1 turn to the right. So 270 degrees counterclockwise is the same thing as 1 turn to the right. So I'm going to show you that. If we turn our paper 3 times to the left, 1, 2, 3. Keep in mind how that image looks. It's in this quadrant here, in quadrant 1 now, okay? Now we're going to start at the original orientation, and we're going to turn our paper 1 to the right. Did it end up in the exact same orientation as when we did 3 turns left? And the answer is yes. So a 270 degree is the same thing as a 90 degree clockwise. So now we're going to plot our image here. So our new coordinates for L, we have to go over 5. We don't go up or down any, so our new coordinates are 5, 0 for L prime. Then we look at K. K, we have to go to the right 5, then up 4. Right 5, up 4. And then M, we have to go right 2, up 3. And that gives us our rotated figure, which looks exactly like it did when we had it rotated. Okay. So keep in mind when you're doing rotations, it's very important to make sure you pay attention to the degree of the rotation, but also the direction, because those significantly change the way it should be. Okay. Now we could have talked about how this was in the second quadrant. So if you do a 270 degree, it would go 3 quadrants and you'd have to be in the first. But I wanted to keep it as simplified as possible. So let's look at some examples. We're going to go through, there's 8 examples we're going to go through. If you feel like you have a good grasp after the first 3, then you know by all means, go ahead and work on the assignments. So on number 1, it wants us to do a rotation 180 degrees about the origin. So again, there's 2 ways to do that. One, you can change the signs on all your coordinates, or you can just physically rotate your paper. Now, if you're doing 180 degrees, your paper is going to end up upside down. So if we do that here, you've got K at -1, +1. That's your new coordinate for K prime. -1, +1. Now, if you look here, this was at 1, -1. So if you change the signs, you switch the signs on both of those, the X becomes -1 and the Y becomes +1, which is exactly what we had with K prime. Now with L is at 4, 0. So we would expect our new point to be at -4, 0. So let's look and see if that's the case. So our new coordinate for L prime would be -4, 0, just like we said. And our last one here, our last one is M. M is at 5, -3. We change the signs on the 5 and the -3, and we get -5, +3. And if we were to have rotated it, you would see that M was indeed at -5, +3. Okay, so you can just change signs for a 180 degree rotation. All right, now let's look at number 2. Number 2 wants a rotation 90 degrees counterclockwise about the origin. So 90 degrees counterclockwise. So we're going to be rotating our figure to the left. So our paper needs to be like this. So we're looking at T, the new coordinates for T. We have to go right 5, down 1. So our new coordinates for T are 5, -1. That's T prime. Then we rotate back and we do the same thing. So V would be 1, 2, 3, 4 to the right and up 3. So 4, 3. And then you have to go right 2, up 2 to get to U prime. Okay. And number 3, Number 3 wants a rotation 90 degrees clockwise about the origin. Remember, this is the same thing as a 270 degree counterclockwise rotation. So you could do a 90 degree clockwise rotation. That means you're going to the right. Okay, so you're going to do one turn to the right. And now your new coordinates for T, you have to go right 1, down 4. So it would be 1, negative 4. Okay. Next up, you do S. So with S here, oops. Yes, I'm sorry. So with S, you have to go left 3, down 5. So negative 3, negative 5 is your new coordinates for S. And then U, rotate negative 4, negative 3. And then that's your rotation. Okay. So if you feel like you have a good grasp on it, you can go ahead and work on the assignment. If not, you can stick around, try these other problems, and just watch how I do them, to get a little bit of a firmer understanding of it. So let's look at number 4. Number 4 says a rotation 90 degrees counterclockwise about the origin. So what we're going to do, since it's 90 degrees counterclockwise, we're going to rotate our paper one turn to the left. So one turn to the left here, and then we just mark our new coordinates. So K would be at 3, or K prime would be at 3, positive 1. So this is K prime. N, I apologize for the light. N would be at 2, positive 3. That would be N prime. 2, positive 3. All right, then M, we have to go left 1, up 4. So that would be negative 1, positive 4. And then I would be at negative 2, positive 3. Or is that an L? I think that's an L. Never mind. Negative 2, positive 3. Okay. Number 5. Number 5 says to do a rotation 90 degrees clockwise about the origin. So that means we're going to be turning our paper one turn to the right. So one turn to the right. Our new coordinates for I, we have to go right 5, up 1. So that would be 5, positive 1. So that's I prime. H, we have to go right 4, up 1. So right 4, up 1. Then J would be right 5, up 4. So 5, positive 4. And then K, we have to go right 2, up 5. So we get positive 2, positive 5 for K prime. And that would be our figure rotated 90 degrees clockwise. Number 6. Number 6 also wants a rotation 90 degrees clockwise about the origin. So again, we're going to be turning our paper 1 to the right. You could do it 3 to the left because that's the same thing as 270 degrees counter, but we're just going to do 1 turn to the right. So our new coordinates for W, you don't have to go left or right any, so you're at 0 for your X, and then you go up 2. So 0, 2 for W prime. Okay, V, you have to go left 2, up 4. So V prime is at -2, +4. Then you do U prime, you have to go left 3, up 4. So -3, +4 for U prime. And then X prime, you have to go left 5, but not up or down any. So your coordinate would be -5, 0. Okay. Last two, number 7 says a rotation 90 degrees counterclockwise about the origin. So a 90-degree counterclockwise would be 1 turn of the paper to the left. So turning our paper to the left now, it's been a while since we've done that. B, you don't go any left or right, but you do go down 1, so it's 0, -1 for B prime. E, or C, I guess I'll do next. You have to go left 3 and down 2, so -3, -2 for C prime. Then D, you have to go left 3, down 5, so -3, -5. And then E, you don't go any left or right, but you do go down 5, so your coordinate is at 0, -5 for E prime. And finally, number 8, your rotation 180 degrees about the origin. We can just change the signs. I am going to do it by rotating the paper, but you can just change the signs, make the positives negative, negatives positive. So S prime, you have to go right 3 and you don't move up or down any. So it's just 3, 0 for S prime. T prime, you go right 1, up 3. So right 1, up 3. And finally, R prime, you have to go right 5 and up 3. So 5, 3 for R prime. And then you just connect your sides. Okay. Now you can always use your formulas that we have, the mapping rules, but most people will find that rotating their paper is physically easier and less taxing on the brain. So I hope this video has helped, guys, and if you do have any questions, please let me know. Just make sure you work on these as well as any other assignments for these. What I would recommend is on the computer assessment or whatever else that you plot these things and then you just physically rotate your paper, because they're not going to let you rotate your computer, but you can rotate your paper if you draw on it. Okay, so just make sure you do that, and thanks guys, and I will see you in the next video.